8 raised to the 3x. And it says that it wants it now to be a base of 2. Okay, and I'll reenact the solution underneath even though you see it. So if I want it to be base 2, then I need to say 2 to the what power gets me 8. 2 to the what power gets me 8. So 2 to the third power gets me the 8. But notice that the 8, it wasn't just an 8. It was 8 to the 3x. So parentheses 3x. And then as you can see, up here I'm going to multiply. 3 times 3 is 9. And so we're going to start translating things into stuff with smaller bases. So number 1, I want this to be a base of 2. I have 32 raised to the x. So the first thing that I would put, if you have no clue what you're doing, is to legit put a 2, because you know the base, the bottom needs to be 2. Then I need to figure out 2 to the what power gets me 32. So you can have a calculator, so just check. So 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16. What gives me 2 to the what power gets me 32? The fifth power. 2 to the fifth power gets me 32. Now what was also up there with the 32? 32 to the x power, so I just pop the x right beside the 5, which is multiplication, because 5 and the x, 5 times x is 5x. On number 3, you'll see a fraction. So it's still the same goal. I still need a base of 5, so go ahead and put a 5. Okay? So that has to happen. Later, it's not going to tell us, but that has to happen. I have to have a base of 5. Well, if I peep the denominator, I can see that it's 25. 5 to the what power gets me 25? 5 to the second power gets me 25, correct? Okay, so how can I change this 25 now into a fraction of 1 over 25? One small detail. I'm going to change that 2 to a negative 2. If you raise this to a negative power, it will flip it and make it and turn it into a fraction. So negative exponent fraction, negative, I need to add the x to finalize that answer. Make sure you have exactly what I squared in here. So you're going to have a left side and a right side. Your goal is to get the right side and the left side to have the same base. Once they are the same base, you can cancel out the bases, set the exponents equal to each other, and then you solve for x just like a normal linear equation. But right now, we have to get it out of its exponential form. So if you look here, and I have a 5, and I have a 125. So 5, I can't go down any further, so I'm going to take the 125, and I'm going to make it a base of 5. So this one does not say make a base of 5, but you can kind of tell just by your bases that we need to convert it down to a base of 5. So if I move my finger here, notice how this whole side pretty much stays the same until I get to this part, because it is already converted to a base of 5. So if it's already converted to a base of 5, then I don't need to convert it. However, on the right-hand side, I need to say, okay, 5 to the what power gets me 125, and that answer is 5 to the third. So 5 to the third gets you 125. Hold the exponent, use distributive property correctly. Then from here, the bases are the same. So take it on your paper because it's not there. I want you to, once these bases are the same, cancel the bases, and you set this exponent equal to this exponent. So the bases have to be the same in order to cancel. Because if it's on the same on both sides, therefore it is equal. Set the exponents equal to each other, and you solve just like normal. So x is negative 2 in that example. So on number 6, the left-hand side already has a base of 3. So what I can do right now is I can go ahead and rewrite that left-hand side just like this, because it already has a base of 3. Now, I still need to have a base of 3 on the left and right in order to even cancel. So 3 to the what power gets you 27? 3 to the what power gets you 27? So 3 squared is 9. 3 to the third is 27. Hold the exponent. Use distributive property. I'll get 3. 4x minus 1 equals 12x minus 9. Okay. Are the bases the same on the left and on the right? The answer is yes, yes. So now I can cancel them, set the exponents equal to each other to get a solution now that will work for both of these. Okay? So, subtract 4, end up getting 8x. Add 9. If I add 9 to negative 1, I get 8. 8 divided by 8, x equals 1. On number 9, notice that I have a 125 and a 25. So let's say I try to do a base of 3. Okay, so 3 squared is 9, doesn't work. 3 to the third is 27, doesn't work. So what would work for this? I would definitely say base 5. Let's go ahead and put a 5 down here. I'll do the right-hand side first, just because the easiest part for me was to say 5 squared is 25. But since it's a fraction and it's 1 over 25, instead of it just being a positive 2, it needs to be a negative 2. So I'll pause for a second. 5 to the negative second is 1 over 25. Put the exact same exponent. I'm going to use distributive property, and I'm going to go ahead and set up this entire right-hand side. So that's what that right-hand side is going to look like. Convert the 1 over 25 to 5 to the negative second. Distributive property, same. If I use a 5 on the right, I have to use a 5 on the left. So these are set up to be this way, where you're getting at the left and the right the same base. So this has to be a 5. So 5 squared is 25. 5 to the third is 125, parentheses x plus 3. Distributive property, 3x plus 9. The left and the right-hand side, same exact base. Cancel, cancel. 3x plus 9 equals negative 6 plus 12. I'm going to add 6 to this side, getting me 9x. I'm going to subtract 12 or 9 to this side to get me 3. I'm going to divide by 9. X is 3 over 9, which simplifies down to an answer of 1/3.